Okay, ladies and gentlemen, we're going to begin lesson 4 in chapter 1 on combining functions. We have 3 objectives, but we're going to focus primarily in this video on just the first 2. So hopefully by the end you can combine functions algebraically, you can find the composite of 2 functions, and you can also decompose functions. Alright, so we're going to begin by using algebra to combine functions. We can add, subtract, multiply, and divide functions just like we do real numbers. The one difference, however, is that you must consider the domain of each function. Alright, and then below I put a chart showing and listing the definitions that we are going to follow in order to add, subtract, multiply, and divide the functions together. Let's do a couple examples. Alright, so example 1, we have f of x. Oh, it's a loud chair. We have f of x equals 4x plus 7, and g of x equals the square root of x plus x. And we want to find what f plus g of x is, and f minus g of x, and then tell their domains. So let's find f plus g of x first. So f plus g of x, alright, how can we break that up? How can we rewrite that? Well, if we look back, f plus g of x can be written as f of x plus g of x. So that's what we're going to do. Once we have it written this way, we're just substitute 4x plus 7 in for f of x. And then we're going to substitute the square root of x plus x in for g of x. Oops. And then we're going to combine like terms. So we have 5x plus the square root of x plus 7. And this is f plus g of x. We now need to tell what the domain is. Alright, so the things to check and be careful of with the domain are we don't want negative square roots, we don't want to be dividing by 0, and we haven't got into this, but in the future we don't like logs. We look here and I notice it's the square root of x. Alright, we just said that we don't want negative square roots, so our domain has to be all positive real numbers. So it's going to be the interval from 0 to positive infinity. Alright, now we want to find what f minus, come on, f minus g of x is. Alright, and then you refer back to your definitions on how to rewrite this. We can say that this is f of x minus g of x. Go ahead and substitute in again. 4x plus 7 will be substituted in for f of x. Now, always write this minus sign here and then put g of x in parentheses. So the square root of x plus x. I do that, I put the negative and then I put g of x in parentheses because that reminds me that I have to distribute this negative. And so I have 4x plus 7 minus the square root of x minus x. Now combine like terms, so I have 3x minus the square root of x plus 7. Alright, so we just found f minus g of x. Now, to finish the problem, we just have to find what the domain is. And similar to the last problem, when we found f plus g of x, we noticed the square root. We can't have negative square roots, and so the domain, So the domain is going to be the interval from 0 to positive infinity again. Alright, in example 2, now we're given f of x and g of x and asked to find f times g of x and f divided by g of x. Okay, so let's take f times g of x first. So f times g of x can be rewritten f of x times g of x. Substitute in f of x is x squared minus 9. It's being a pain in the butt right now. Alright, so f of x is x squared minus 9, and g of x is x plus 3. And so what we have to do now is FOIL. So x squared times x is going to give me x cubed. X squared, the outer part, so x squared times 3 is 3x squared. The inner parts is negative 9x. And the last part's 9 minus 27. So this is f times g of x. Alright, the domain, I look at this and I don't see any logs, I don't see any square roots, I'm not dividing. Alright, and so the domain, there's really going to be no constraints on the domain, so it's going to be all real numbers, and we can represent that with this interval from negative infinity to positive infinity. Alright. Next one, we need f divided by g of x. We need to find this. Alright, refer back to your definitions. We can rewrite this as f of x divided by g of x. Alright, so here we may have to be careful. We don't want to be dividing by 0 here. So we'll get to that in a minute though. So substitute in for f of x, so that's x squared minus 9. G of x, that is x plus 3. Alright, and so this is f divided by g of x, so we can circle that. Our work is done there. But for the domain now, alright, we look and we're dividing, so we can't divide by 0, so the denominator can't be 0. So what we're going to do is set x plus 3 equal to 0. We're going to find out what x can't be. And what x can't be is negative 3. Alright, so we have to leave that out of the domain. How are we going to represent this, or how are we going to write this as an interval? Well, the domain can be from negative infinity up to 3, but it can't be 3. Alright, so that's why we're going to have parenthesis there. It can be in that interval, or it can be in the interval from 3 to positive infinity. Alright, and notice all of those parentheses, those are all parentheses. We're not closed on any of those intervals. Alright. Okay, so next we're going to get into the composition of functions. So this is the second objective that you guys want to be able to do by the end of this video. And so a composite function is a combination of two functions such that the output from the first function becomes the input of the second. What we're going to be doing with the composition of functions is basically plugging one function, the inside one, into the outside function. Alright, and some notation here. If we look at this, be aware that that is an open circle, and that is read of. So this is f of g of x, and we can write it like this. Also note down here at the bottom, that function composition is not commutative. So what does this mean? So f of g of x is not going to equal g of f of x. So these two things right here aren't going to be equal to each other. Okay, so in example 3 here, we're asked to solve a composition of functions. Alright, so we have f of x equals x minus 5, g of x equals x squared. And what we want to find is what we need to find is g of f of negative 3. So what I would do is find what, oh boy, what is that? We want to find what g of f of x is, and then whatever that function is, plug negative 3 in for it. Alright, so g of f of x equals g of f of x. And so I like writing it like this because it really, you can kind of see what we have to do. We got to take f of x and plug it into g of x. Right? So everywhere we see x in g of x, we're going to plug in x minus 5. So we have x minus 5 squared. Alright. And then that is our f of g of x. Okay. And so now what we're going to do is we're going to plug in negative 3 in for x. So g of f. Let me erase this. There we go. So now we're going to plug in negative 3 in for x. So negative 3 minus 5, and then we're going to square it. Alright, negative 3 minus 5, that gives me a negative 8 squared. So it's going to equal positive 64. Okay, so when you're asked to find the composition of two functions, it's also going to ask you in the problem to find the domain, and this is pretty important. When finding the domain of a composition, you want to find the composite function first. Alright, and then once you have this function, work out the domain before simplifying the expression any further. Alright, so in example 4 here, we have f of x and g of x, and we have to find the domains of the following functions. So we got to find the domains of g of f of x. So g, gosh, this thing is sensitive. G of f, alright, that is equal to g of f of x. Alright, so let's find this composite function. So I'm going to take f of x and plug it in to g of x. So here is my f of x, and what I'm going to do is everywhere I see x in g of x, I'm going to plug this in. Alright, so I'm going to have the square root of 1 over x minus 1. Alright, so this is g of f of, g of f of x. Alright, so we can circle this. Alright, and then to find the domain, alright, got a lot of things going on here. Alright, the first thing is that x minus 1, alright, that we can't have 0 in the denominator, so x minus 1 can't equal 0. So, come on. So x cannot equal 1. Alright, not only can't x equal 1, but notice the square root. Right? We cannot have a negative square root. And so if x is anything less than 1, notice how this, what's underneath the radical, is negative. Alright, so our domain is going to be the interval from 1 to positive infinity. I want to point out that the domain cannot be 1, and that's why I have the parenthesis on 1. Okay, in part B here we have f of g of x that we have to find. So we have f of g of x. Alright, and so what I'm going to do is I'm going to take the square root of x and substitute it into in for x in f of x. Alright, so I'm going to get something that looks like this. 1 over the square root of x minus 1. And I forgot to mention this in the previous example, but before we started this this example problem, we talked about how that when you were finding the domain of compositions, that you wanted to find what the composition function was first. Okay, so this is the composition function. Alright, now sometimes you're able to simplify this composition function, but in this case we can't. Alright, we can't simplify it any further. But if you could, you wouldn't want to simplify it. You would want to find the domain first. So at this step here, you would want to find the domain, and then after you found the domain, then you would go ahead and simplify. So we don't have to worry about that in the last two that we did. So, but I just wanted to make sure, I wanted to point that out and make that clear. All right. So what's the domain going to be? Well, I can't have a, first thing that strikes out is I can't have a negative square root. All right. So x has to be greater than or equal to 0. All right. Now, what happens if x is 1 though? Alright, so if x is 1, alright, notice the square root of 1 is 1, and then 1 minus 1 is 0, so then I'd be dividing by 0. So x is greater than or equal to 0, but it can't be 1. Alright, so the interval, how we're going to write this, is closed on 0. Alright, but then we're going to be open on 1. So it can be in that interval or it can be in this interval, from greater than 1 to positive infinity. Alright, so there's the domain there. Okay, the last example, the last topic is the decomposition of functions. Okay, so this is going to be the opposite of composing them. Alright, so when we decompose function, we reverse the process of composing them. And then again, it's important to point out that we work from the inside out. Alright, and so in example 5 here, we want to find a f of x and a g of x so that the function can be described as y equals f of g of x. And we're going to let y equals the square root of x squared plus 1. Alright, so what we can say here is that f of g of x, alright, that equals y, and y equals the square root of x squared plus 1. Alright. Okay, so g of x here is what is inside. We're taking g of x and we're plugging it into f of x. Alright, so what is inside over here? Well, it's going to be the x squared plus 1. So my g of x equals x squared plus 1. And what did we plug the x squared plus 1 into? Well, we plugged it into f of x. And what was f of x? Well, f of x was just the square root of x. Alright, and so we can check to see that we are right here by saying, okay, so we have f of g of x. Alright, and so here's g of x. So we're going to take x squared plus 1 and plug it into the square root of x, or f of x. Right? And so you'll notice that you get back the square root of x squared plus 1. Alright, so that's really what decomposing a function is. So I hope this video made sense, and I'll be working on the homework problems in class tomorrow.